All right, so this question was from the 2013 exam, and we just sort of had a bit of an argument about what is the volume formed by the revolution of just the line y equals 3x. Now, I did say to you that the volume of this shape, just this one here, we know that if I had 3x, and if I rotated that about the x-axis, then that's going to give me some shape that looks like this, which is, it is a cone, isn't it? And we could use the volume of a cone formula. But at the same time, each one of these, we know that the area of a circle, is pi r squared. The area is equal to pi r squared. But each of these radiuses is the same as the y coordinate. So I'm going to replace r with y, pi y squared. So if I integrate between 0 to pi on 3, don't forget the pi, I'm going to put that out the front, and that is y squared dx. But what is y? Y is 3x, isn't it? Yeah. So let's just find the volume of that, just for the time being. Now I'll show you how to do it in just sort of one step. That's where you want to get to. So I'm going to say that that's pi, and y is 3x. So that's just 9x squared. 9x squared dx. And I'm then going to say that that's 9x cubed over 3, which is 3x cubed from 0 to pi on 3. Is that correct? Indeed. Let's throw pi on 3 in then. I've got 3 pi times pi cubed on 27. Which is equal to, what have I done here? Pi r squared. Oh, that's squared. What have I done?
You've done everything right.
It's right?
Yeah.
Okay.
You forgot the pi on the other one.
I forgot the pi on the other one. So there's that pi to the power of 4?
Yeah.
Over 27.
Over
9, sorry. So we did forget it, didn't we?
Yeah.
Good. So we've just acknowledged you, Lockie. Excellent work. Now, so that's our volume of that. Now, what I wanted to do, though, is if I wanted to rotate about anything, what we've actually done is we've rotated and found that volume there of that big one. But if I was to subtract, oh my goodness. If I was to subtract the volume formed by rotating the graph of sine of x, then I'm actually going to get, so if I was to rotate, now be careful, that's not just a line, but let's just pretend that, then I'm going to get the volume formed by this shape here, rotating it. And it is hard to visualise. You don't really have to visualise it. I've shown you the video, but you don't really need to, you just need to be able to work out what it is. So I know that some of you really struggle to actually visualise it, what it's going to look like, but you don't need to. So let's go ahead and I'll show you. Now, I did show you the method of the cone method. If you wanted to do that, you could, only because this does form a cone. And how did we work out what the volume of the cone was? Well, what did we do? What's the volume of a cone? Isn't that a pi r, a third? Pi r squared h, yes? Now, we know that the third stays out the front, and we know that pi is pi, and what's r? The radius is 3. Yeah? 3 times, what is it?
3 times
pi on 3. Is that the radius?
Yeah.
So that's squared, isn't it?
Yeah.
Yep, good. And what's the height? Pi on 3. All right, let's do that. They're going to cancel out, pi squared. So we've got pi to the power of 4 on 9. So we can use it in that case, but a lot of the time you can't. You certainly can't use it on this one. So if I was to find the volume, this is what I would do if I was setting this out. I would say that the volume of this shape is equal to 0 to pi on 3 of 3x, be careful, squared dx, subtract 0 to pi on 3. That pi has to, but be careful. A lot of you forget that pi, and I just did too. Subtract pi. Now be careful, it's sine squared. You cannot sine of x squared.
No square. There's no square.
Yeah, there is. There has to be. This is where you've got to be careful. Think about what's the radius of each of these circles? The height, y. What's the area of a circle? Pi r squared. Okay. Now, can I just draw your attention to something? A lot of students, I've seen a lot of students do this. They do this, 3x minus sine of x all squared. Can you do that? No. If you do that, it's probably because you didn't listen to me. Okay? I'm telling you, go. If you watch this video again, I'm going to tell you not to do that because it's not equal. Okay? That is not equal. That is not equal to 3x all squared minus sine of x all squared. Okay? It's not. So don't do it. All right? Now, I'm going to just rub that out and I'm going to fix this up now. Now, let's finish this. I think this is worth 4 marks. And this is in the 2013 exam, so let's do it. Well, I'm going to skip a step because we know we've just worked out that that's pi to the power of 4 on 9. We've done that before, haven't we? Okay, and you could have found that using the cone. And I'm going to subtract, that is going to be subtract pi out the front. What is 0 to pi on 3? What did I do with there to the sine of x all squared, or sine squared of x dx? What did I do? Double angle formula. Okay, so from memory, didn't we have cos squared of x minus sine squared of x is equal to cos of 2x?
Personally, I would use the 1 minus 2 sine.
That's right. Okay, good. Which is just, that's where that comes from though, isn't it?
Yes.
So we've got cos of 2x is equal to, isn't it 1 minus 2 sine squared of x?
Yes.
Awesome. So if I rearrange, I could then say that, I get the 2 over there, I can say that 1 minus cos 2x is equal to 2 sine squared of x. And we could say that sine squared of x is equal to a half 1 minus cos 2x. Is that right?
Yes.
Awesome. Let's replace that now. So I'm going to just rub that out because you can just replace that sine squared x with that. And you would have done that enough times, you should realise that, but I would do that on the side. And that is equal to pi on 4 on 9 minus pi, and that is pi on 2. What was it? 1 minus cos 2x.
Yeah.
Dx from 0 to pi on 3. So let's go finish that off. Pi on 4 on 9 minus pi on 2. That is outside of x. Antiderivative of minus cos is minus sine 2x
Half sine 2x.
on 2.
Yep.
All right. Let's not get carried away. It's all right. All right, and that is equal to, so subbing in pi on 3, minus pi on 2, pi on 3, sine of, what's sine of 2 pi on 3?
That's root 3 on 2.
Root 3 on 2, so that's minus root 3 on 4, thank you. Is that it?
Yeah.
Good, because 0 is going to cancel out, isn't it? Is it? What sign is 0?
0.
Good, okay. Just making sure. So that's pi to the power of 4 on 9 minus pi squared on 6 plus root 3 pi over 8. Would you go any further? Nah. Let's have a, Let's have a look. What was that? Let's have a look at the 2013 question. It was the last question from memory. Question 9. It's worth... We'll get rid of that. So let's go to... Where are we? Examiner reports 2013. Oh my goodness. I'm just going to pause it. All right. There we go. Now, what does the examiner report say? Question was... Question was well done by some students and poorly by others. Common errors included getting rid of the pi, which, believe me, a lot of the time it happens. If you remember that this is actually coming from the area of the circle, don't forget the pi, because area of the circle is pi r squared. And also using 3x minus sine of x all squared. I told you that a lot of students do that, didn't I? Well, don't do it, please. The double angle formula not being used. And so, look, but that was a pretty basic question. But at the same time, I think from memory, it wasn't that poorly. Only 29% of students got full marks. And alarmingly, 40% of students got 0. Don't be in that. I'd like to at least get 3 marks, but there's no reason why you shouldn't get full marks. A lot of the time it's just calculation errors, which quite a few of us are still making silly calculation errors in SACs, and we don't want that in exams. All right, now I've done that question. What I'm going to get you to do now then is I've told you about finding it for the y-axis. Now let's go ahead and do it another one. And this time... No, that's another area one. We've done that one. Find the exact area enclosed. Now, this is a bit of a trick one. Find the area. No, we won't do that. This time I'm going to get you to have... All right, let's do this one. Be careful, right? How many marks is this one worth?
1.
It's worth 1 mark. So do you think it's going to be a super duper hard thing?
No.
No. I'm going to pause this question. Have a go at it, please. All right, so we want to find the area. It's only worth a mark, but I'm just going to take this over here. And Ben, what did you're going to explain what the area for this is. Bearing in mind, I'm going to draw a little rectangle there. And what do you notice about your inverse cos of x graph in terms of its properties? What's the area for this, Ben?
Because we know that inverse cos is symmetrical, if we draw a square around it, we know it's going to be exactly half of that square.
Beautiful.
So we can see the distance from -1 to 1 is 2, and it goes up to pi. So the area of that square is 2 pi.
Beautiful.
I want half of that, so half of 2 pi is pi.
Area. Now it's worth 1 mark. So just write the answer. Area is equal to, unless it's asked you to show something, which you can do. Area is equal to a half of 2 pi, which is equal to pi units squared. Beautiful. Well done. Now, this time we're going to the next question. Now this is from the 2008 exam, but this time find the exact volume of the solid of revolution formed if the graph is rotated about the y-axis. Now, we talked about this, didn't we? Now, well, first of all, the graph is rotated about the y-axis. So, I might just draw it again, but we've got the graph which looks like this, and we've got, it's a terrible graph, isn't it? That's -1, that's to 1. Now, I'm not sure, like if you were to do half of it, do you think that maybe you could times it by 2? You could do that. But remember, if we're rotating it about the y-axis, oh my goodness. If I was rotating about the y-axis, what do I have to get? Like, I've got the y-axis as, well, the volume is equal to pi r squared, and r is y. Oh, no, r is what? R is x. So it's pi r squared dy, isn't it? Because x will be in terms of y. So what do you have to do? We've got y is equal to inverse cos of x. How would I get as a function of x as a function of y? What's that? Take cos of both sides. So x is equal to cos of y. Is that correct? Ah, interesting. Good. Now, the thing is, though, if I'm rotating, rather than doing the integral from -1 to 1, that's not the case. We're looking at y values. So we're looking for the y value here, or the y value here, and the y value here. So we want to start from the lowest y value to our highest y value. So this isn't -1 and 1. This is 0. And what's the other one? Pi? We okay with pi? Okay, now have a go at that one. So what I would do always when doing these is I would start with y is equal to inverse cos of x, and I would get x in terms of y. X is equal to cos of y. And then I would just write down as a side note to show the examiner I know what I'm doing, x squared is equal to cos squared y, isn't it? Then, therefore, I'll say that the volume is equal to, and I might even write, I would find the values of 0 and pi, and I would just do that. And then I would say that the volume is pi outside of 0 to pi of x squared. I'm just going to say cos squared y dy. And
That gets 0.
sorry?
That gets 0.
That gets
0, I think. No, it doesn't.
Now what's cos squared y?
Oh, yeah.
Isn't it 2 cos squared y minus 1 or something? What's the... I've got to use the double angle formula.
Minus 2.
What is it?
It would be cos 2x minus 1 over 2.
So cos 2x minus
1
oh,
over 2.
plus 1 and is equal to
No wonder.
cos squared y. Brilliant. So let's replace that now. I'm going to replace that with pi over 2 now. 0 to pi. Cos of... Sorry, my apologies. That's y, of course. Cos of 2y plus 1 dy, which is equal to pi on 2, 0 to pi... Oh, look, don't know what I'm doing. Sine of 2y on 2 plus y from 0 to pi,
It'll be 2 pi, which is 0.
which is equal to sine of 2 pi on... Yeah, so that's pi on 2. Sorry, sine of 2 pi is 0 plus y.
Which is pi.
So that's pi
And then it's just going to be minus 0.
minus 0. Yeah, okay. Which is equal to pi squared on 2. Is that correct?
Yep.
Good. Now, let's just see how students... I don't think they would have done as well because they might not have recognised, defined, they might have not known how the formula works. If you know how the formula works, it's not so bad, is it? It's pretty straightforward. It's like the area of a circle. So I'm going to just pause it now, and I do have this... All right. So can you believe that 72% of students couldn't recognise that this inverse trig function was symmetrical in that, and you couldn't work out pi units? And amazingly, 55% of students got 0 or 1 mark. In other words, if you make calculation errors early, you don't get consequential marks for doing it. If you stuff up early, you don't get the mark. There's no argument. Like some of us were looking at our SACs and said, yeah, but this fraction was supposed to be 1 over 4, but then of course I've done the right. It doesn't work that way. They're really quite, if you don't get to this line, so a lot of the time it's really hard to get 2 marks. You can see there that it's hard to get 2 marks. Only 8% of students got 2 marks. So you'd sort of either get 1 or you'd get the whole mark, all right? And if you could get to sort of that if you could get to that step, then you'd almost guaranteed full marks unless you did something stupid like leave out a dx or dy or whatever. So, quite a poorly done question, but it's pretty straightforward, isn't it? Is that straightforward? What do you think, Ben? You've only done 2 of them.
I wouldn't say it's straightforward.
Oh,
But, like,
I reckon once you do it, I reckon it's now time for you guys to have a practice at 8D.
Yeah.
All right, away you go.
8C.
Is it 8C?
No, 8D.
It is 8D. 8C is just stuff on your calculator.
So don't do 8C.
Well, do it, but do 8D today. How much time do you have left? Probably not much.
About 5 minutes.
Did you just say that 5 minutes?
Where did the time go?